Hi, I'm Paul Kreischer. Welcome to Heart of a Building. This show dives into the building designs that are cutting edge, really pushing the envelope of sustainable living. Along the way, we'll also explore the motivation from the people involved in these great projects. In short, the why. Today we're in Denver, Colorado in the Central Park Northfield neighborhood, nestled against the Rocky Mountain Arsenal Wildlife Refuge. Central Park is known for its focus on the environment, and all the homes built here have an ENERGY STAR requirement. ENERGY STAR's purpose is to help home buyers easily identify homes that are at least 10% more energy efficient than homes built to code in the marketplace. But Thrive Home Builders goes beyond ENERGY STAR. They have a decades-long history of being an industry leader along with a slew of awards to prove it. So let's go take a look. Thrive installs solar PV on all of their houses to provide 100% of the electricity for their net zero energy homes. Now, do you know how much solar PV has been installed in Colorado and how much power it provides? Find out at the end of the show. Thrive has been around for a quarter of a century, spearheading the push for sustainability at the direction of owner and founder Gene Myers. Everyone involved in the design and building of these homes is focused on net zero emissions for the environment and the highest indoor air quality for their residents. Before we dive into the design details and find out about all the cool green features, let's find out about the why. Gene, a pleasure. I've known you for a few decades, I guess now at this point, but both getting a little gray. But it's a pleasure to sit down and talk with you because you have been an inspiration for me in a lot of ways. And I know you've inspired many others in the building industry because you've walked your talk. Being the person that you are, I'd love to hear the why for you.
Well, you know, depending on when people ask me that question over the course of my journey, I probably had slightly different answers. I think the fundamental reason for why any high-performance builder does what they do is because they think it's the right thing to do. And then we kind of come up with business justification for what it is that we believe should be done.
But you've been an inspiration and a mentor, or at least a target for other builders to be shooting toward. How do you see that as part of your mission?
Well, you know, I've been criticized in some parts of my career for not being a real zealot and out there shaming other builders. And I just have such a healthy respect for how hard it is to be a builder. And so it's been more important to me that our actions speak louder than our words. It's not to say that every builder should look like us. Some people are so passionate about affordability or
it's very important.
Other very important aspects of housing that I respect them just as much. I've never been concerned about, well, will people follow? But I think it's upon us that, again, if we have this knowledge and we have this ability to basically bring all of these resources and talent and drive to the service of our customers, well, that's what a good builder ought to be doing.
Bill, the walls in this place are certainly unusual. I've seen them on a few occasions, but it's great that this is what you do standard practice. But this double frame wall assembly so you can have great insulation and thermal break. Tell us some of the details of what you do with this.
Yeah, absolutely. This is a 9.5-inch thick wall.
Yeah. We
frame with two separate 2x4 walls. And one of the things that we do is we put a 2.5-inch air gap in the middle. That allows a thermal break so that you're not conducting heat all the way from the outside through a full set of lumber to the inside. There's a break, and we can fill this area with insulation.
Because normally, I'll just add to that, normally if you have the stud connected directly to the outside, that's a thermal bridge. So warm and cold transfer through this more readily. So that break is so important in making a great envelope. But
we've maximized that break by offsetting the stud, so I get a full 6+ inches here and 6+ inches here, and then 9.5 inches all the way through, giving us an R39 wall, which is super insulated.
There's many attics that were recently built that didn't have an R39 in them. And you put a wall, like that together. That's such a huge part of what makes it so comfortable and such low energy.
Quiet too.
Yeah, so quiet, exactly. So get rid of the neighbor's noise by having a great wall assembly. So I think that's great. So tell me more about some of the details you do for air sealing, to tighten up, because that's great insulation, but You guys have a great airtight envelope, so what do you do there?
Yeah, that's right. So air tightness is obviously very important to energy efficiency and to health. And so we make sure that we're foaming all gaps and cracks at the plates and in the framing. We also add a 2-inch layer of open cell foam along the rim. Rim tends to be one of the leakier areas of the home.
Right.
So we try and focus most of our air tightness practices in those areas where the leakage could be the greatest. The rim joist between floors is one of those areas. So we skim coat it with a skim coat of foam to tighten that up. The next is attic wall intersections where a wall meets an attic space. Right. And in there we use a foam that's extruded out of a can, but it doesn't harden, it remains soft.
Okay.
And so when you put the drywall on it, it compresses that and creates a gasket, making an airtight seal in that leaky area of the home.
Weather stripping the drywall to the top plate, to the wood, basically. That's outstanding. So another area in the envelope are the windows, which, again, these are well above average Energy Star windows because you have a U value that's a 0.24 U value. So that's essentially an R5 window.
Right.
Energy Star requires like a 0.3, or lower.
Yep, so windows are obviously a really important aspect of the home. One of the things with an energy efficient home, if I took all the windows out, I would make a much more efficient home. Right. But I'd also make a home that's not very pleasant to be in. Right. We'd be using a lot of energy for lighting. So we have to really balance the location, the size, and the placement of windows to maximize the light and the openness for the home, yet still make sure that we're focusing on energy efficiency and that insulated wall value that window is a part of. Right. And having very well insulated, low U value windows as a component of that really helps us maximize the amount of light that we can bring into the home.
Oh, that's great. And like I said, the solar heat gain coefficient is the amount of the sun's heat that that's let through the window, so the amount of heat coming through the window. So in this case, there's only 20% of it. So 80% of it is reflected back when the sun strikes it. So so much easier to keep it cool in the summertime. So it's outstanding.
Another important component of the double framed wall are the header locations above windows. You'll see on this one, we have the header location on the outside wall. In a typical framed wall, that would fill the wall cavity and provide you very little to no area for insulation. In this double 2x4 wall, we're able to keep that structural member on the outside wall and fully fill inside of that, insulating on the back side of that header, creating a fully insulated wall and minimizing the thermal bridge that would come through that otherwise solid piece of lumber.
Now, one of the key things that I know that you had as a guiding principle was to work on this project to help reduce some of the costs on the exterior side of it so they could put more into making this house perform so incredibly well. But you didn't take anything away from the beauty of it, as I see it. So how'd you do that?
Well, the nice thing with that was the key design driver for the elevation, the exterior for this home was this farmhouse style. And what's so great about that style is that it's very simplistic by nature. It's very form-based, so we have the big gable end forward on the front elevation. The rest of the roof form is very simple, front to back. Keeps that form really simple and also accommodates solar panels really efficiently and effectively.
Integrated design thinking is what it sounds like, thinking about how all those things would come together as part of this bigger team. Basically, we want to take a great look at the solar PV systems on these homes that Thrive's built. The model home here in front and many others down the road. Many homeowners would say, can't I get a home comparable to it without solar, and wouldn't that be less expensive for me?
That's part of the formula that we have to work with, is we do want to deliver that power at a cheaper cost than they can buy it otherwise.
So to simplify this, Sunnova's coming in and really replacing the local utility, as it were, in the agreement with the homeowner. Instead of them paying a bill to Excel, they would pay it to Sunnova if there was to be a utility bill?
Augmenting's maybe a better way of putting it. We're still in partnership with the utility.
Okay.
Solar, especially on new homes, I think is really a win-win-win scenario for everybody.
You've been involved with Thrive on 288 homes?
In the Central Park neighborhood, yes. Yeah. Well, you've actually done more solar than that. That's just with our company.
Okay.
So
we put our first solar on homes here in Central Park in 2009.
Yeah.
So it's been a long time. I didn't have white hair back then.
288 homes you've been involved with. Do you have a sense of how much that's helped reduce the carbon footprint? as far
So
as of these homes?
yeah, so we're probably, now these systems are a lot larger because we're shooting for a little bit different goal in these homes.
Right.
Probably most of our systems average around 3 kilowatts of
Okay.
solar.
And how
This
big
one's
is this
about 7.28,
Right.
so a lot larger. But on average, we're probably, I think just with the 288 homes we've done, we're probably around over 3 million pounds of carbon offset annually.
Annually.
With those 288 homes.
That's outstanding. So now I get to be down here in the lungs of the house with Bill Rectanis. One of the things I want to touch on is like right over our shoulders is like this air source heat pump water heater.
Right.
Pretty innovative, not common. You can get them now at Home Depot and places like that, but they're still pretty new to people.
Right.
Why did you choose it, and what have you liked about it to this point?
Well, there's two reasons that this is a real benefit for us, and one is that there's no combustion. When we're looking at building a home with good indoor air quality, one of the first things you can do to help that is get the combustion out of the house.
Right.
Get out anything that could potentially put pollutants into the air. And with this being electric, it's sealed up. It doesn't have any combustion inside the home. The second thing is the heat pump side of it. It's using the air in this room to help heat the water.
Right.
And it's super efficient in what it does. And so we're using a lot less energy while we're heating the water and creating a safe indoor environment at the same time.
The same type of technology. I mean, it's the same technology that's in a refrigerator, really, right? And you guys are just being smart about using it for heating the hot water.
Right.
Yeah, so that's fantastic. Sean, thank you for being here.
Happy to be here.
Yeah. This product, not a lot of people know about air source heat pumps, certainly in Colorado. It's still new to the industry, new to buyers of homes or retrofitters of homes.
Well, cold climate heat pumps are definitely getting a lot of attention. Air source heat pumps have been around for a long time, but looking at cold climate specific equipment, that's where Mitsubishi and a few other high quality manufacturers are starting to really hit the ground running. So looking at a full size air handler like this is something that's pretty new to most people, where we can take the return air, heat it up, cool it down, regardless of temperature outside. This system will take care of the house regardless of what temperature this house will see throughout the year.
So there's no natural gas backup, like I know sometimes there are.
Exactly.
Okay.
And just in case, we have electric resistance backup,
Okay.
but we expect to see that use be very, very small.
Okay. So really quickly, an air source heat pump, just so folks know, think of about, many of us have air conditioners, so think about it like that. What it's doing is instead of just doing cooling, it runs in reverse and provides heating as well. So as you can see from the unit outside, the condenser outside, it looks like a conventional air conditioning unit, just a little bit taller, and then provides heating and cooling.
So HyperHeat is our version of a cold climate heat pump. It's different technology, there's different guts in this thing. It does different things at cold temperatures.
So it wouldn't need HyperHeat like in Florida or South Texas, but here in
Exactly.
Colorado and Minnesota, New
Exactly.
York, places like that, you need that. Otherwise, you're not going to be able to maintain the heat that you need for the space. So that's
One of the things that it does is actually has an additional refrigerant loop, and it actually pulls off additional waste heat from the compressor.
cool.
And it has an additional heat exchanger within within the system to actually capture more heat that's coming out, unused heat that's coming out of the house, if you will, right?
Okay.
So there's these different engineering technologies that kind of come into play that allow for modern heat pumps to do cold climate work.
Well, now I get to hang out with Russell Pope. Indoor air quality obviously is what you guys do. Downstairs they have actually a recovery intake in
Right.
here to balance that. Very few home builders actually include that. They put a bath fan and say, oh, our house is going to be leaky enough and who knows where the air is coming from.
Right.
But what you guys did in conjunction with Thrive is you make sure you know. So how does that, can you tell me more about that? How that
Yes,
works?
so it's really important, and it all starts really as far as the needs for ventilation increasing as builders have become more energy efficient. They build a tighter house. So where the house used to be leaky, you know, on a windy day, you would feel drafts in your house, right? And the reality was, like an old farmhouse that's leaky has great indoor air quality unless there's something happening
Yeah,
outside.
if there's a fire like we're having around this area, right?
Right. But situations like this, you build a house to have a tight building envelope and keep the things that are outside out, and you know, you retain your heated and cooled air, for example.
Right.
Well, what that does is you're limiting your ability to have fresh air from outside.
Right.
So you really want a balanced ventilation system. So what we're doing here with these fans is there's a basic minimum ventilation strategies that say, you know, on an average home this size,
Right.
you should ventilate this amount of air.
Right.
So we've got the ventilation fans set up so that they automatically exhaust a certain amount of air. The energy recovery ventilator will do the same thing. So I think actually in this home we have the energy recovery ventilator providing that minimum ventilation requirement.
Okay.
Then throughout the house we have indoor air quality sensors that create a demand-based ventilation system, which is something that's really important because you know, the minimum ventilation standards are important, but they don't capture everything. What if you're having a dinner party and there's 15 people in your home?
Right.
Right?
Yeah.
What if you're a retired couple and you never cook at home?
Right.
At a big house like this, with the other things that Thrive has done with the filtration, a lot of times you don't need as much ventilation exhaust air as you would if you're a family of 2 with 3 kids. You cook twice a day and you're homeschooling the kids for whatever reason. So there's different ventilation needs that also contribute to the environmental and the energy impact of that.
Right.
Because if you're exhausting more than you need to, you're wasting energy by getting rid of air that's already healthy, and then you have to bring it in, heat it, cool it, humidify it, dehumidify it, do whatever else you need to do to make it comfortable for the
Exactly
occupant.
right. Can you tell me more about the sensors that you have, you know, here?
They're sensing carbon dioxide is actually an algorithm. It's based off of the volatile organic compounds.
Okay.
And it's kind of relevant. Hey, the VOCs are this, then the CO2 is about that.
VOCs are volatile organic compounds that come from everything from, you know, like your soap, your deodorant, the things you cook, carpet, you know, things like that. So it's reading that and then doing an algorithm to judge the carbon dioxide.
Yeah.
Okay.
So if the VOCs are elevated, we can automatically turn on fans, for example. So we actually have a scene set up in this home that if the VOCs are high in the kitchen, it automatically turns on the range hood.
That's awesome.
Yeah.
People probably get a little startled, like, what the heck just happened? You know, the
Yeah.
house is smarter than I am. But
Yeah.
Okay, but that's really good smarts because our noses don't pick that up most of the time.
And a lot of times we're inadvertently making it worse when we do things like burn candles.
Sure.
Or
right.
we're using the
Air
plug-ins,
fresheners,
the air
yeah.
fresheners. They're
Those can
really
be really bad. Right.
significant contributors to poor indoor air quality, but
Right.
people utilize them to diagnose an indoor air quality problem that they're not aware of.
Right.
If you get fresh air in, then you get that feeling of fresh air and you don't have the need for candles or,
Right.
or
Exactly.
these other things.
Right. You know, indoor air quality, like I said, it's been a hot summer, smoky summer with all the forest fires. Has that been beneficial for you as far as, you know, is it good indoor air quality or is it a bit dusty inside the home?
Well, overall, it's very clean. Just being a new homeowner, my house is one of the first ones done, and I kind of live in a construction zone now.
Right.
So you can kind of see the dust accumulate on the outside of the house or, you know, in parts of the road or, you know, whatever it may be. But inside the house, you really see little to no dust just kind of accumulating on a countertop or a table or a mirror.
Right.
So it's so far, I'm very happy.
During COVID, we started thinking of health in a different way. When you start thinking about health in the home, most people go to indoor air quality because it's a really important component of being healthy in the home. But as COVID hit, sanitation comes into mind.
We've also added to all of our options now an effective and pretty affordable, healthy home packages, which will expand on what we already offer as a standard feature, including a whole house steam humidifier, electric toilets that are self-cleaning.
Really? Okay.
Yes, so there's
We got
so many.
space station.
Space station.
That's fantastic. I want a self-cleaning toilet. That's fantastic.
And it's heated too.
Okay. In a net zero energy home, nonetheless. Okay.
What more could you want?
Exactly. So now Bill's giving us a quick tour of their cool Jetsons-like technology that they have for cooking. They have an induction cooktop. So Bill, tell me a bit about this. Zero emissions, right?
Zero emissions, obviously. This is an electric cooktop. However, it's much different than the electric cooktops we're used to. This one cooks using electrical waves. And so you need a magnetic pan to work on it. But when you have that right pan, it heats up almost instantly.
So
The
like
burner
natural
never
gas.
gets hot, so if you spill stuff over the side, it's not burning on your cooktop. And like you said, it eliminates that combustion that's going on in the home, creating bad indoor air.
That's outstanding. Would you mind doing a demonstration of how this thing turns on?
Yeah, this is great. One of the great things, or one of the neat things I really like about this is the knob. It comes right off. You just slide it using a magnet from whichever burner you want to use. You crank it up. And there's a little faux blue flame here so that you know which burner you've turned on, because it doesn't get hot.
Yeah, you won't burn yourself, but yeah, it would only conduct into the pan.
That's right.
That's outstanding. That's great technology and great advancement. So thank you for sharing that, Bill.
You bet.
Recently, I sort of had this aha moment, you might say. We're sitting here in the fall of 21, and in the fall of 20, we had been through the lockdown with the pandemic. And in Colorado, it was hard like everywhere else, but we had this beautiful, great outdoors we could always go into. And it was about this time in 2020 when I was sitting isolated in my home office.
Right, like so
and I
many
was
of us.
looking out the window at the smoke from the wildfires, and I think the connection between these frequent events in the West particularly, and climate change is well established. And it occurred to me that, well, if you're locked down and you can't go outside, maybe home is the last stand. And therefore, maybe the health of the air we breathe and the connection to our health it's not just a refuge, but it needs to be a place that is really a safe place to be. And so it dawned on me just a year ago that maybe what we're really about is the health of our customers, but also the health of the planet. Because by treading lightly on the environment, by being an energy efficient builder, by having a low carbon footprint, we're doing our part for the planet, but in the end, that's important to all of us.
Do you know how much solar PV has been installed in Colorado and how much power it provides? As of spring 2021, there have been nearly 1,756 megawatts of solar PV installed in Colorado. That's enough no-emission electricity to power 340,720 homes across the entire state. Truly inspiring. The way they've evolved the construction of these homes over the years to lead to these net zero energy, zero emission, and high indoor air quality houses. It genuinely reflects how much they care about their buyers and the greater environment. It takes a team of knowledgeable and skilled people who share the passion to build the best. I love that Gene and his team are committed to continuing to push the envelope to keep finding ways to fully reduce the environmental impact as well as the cost to buyers, to make their housing ever more in harmony with nature while being more affordable and obtainable for an ever larger section of the home buying audience. We look forward to staying in touch with them and seeing what they produce next. I'm passionate and spiritually called to share these stories. The primary reason is buildings and their construction are the source of nearly 40% of the emissions that are exacerbating global climate change. We hope these stories inspire you to look for homes such as this, or to bring many of their performance details into your current home. Let us know if you do, because you may just end up being showcased in a future episode of Heart of a Building. Thanks for joining us, and we will see you next time.
Happy homeowner dance.